After making our dilutions, we transferred some of the stock and the dilution solutions using a pipette into the cuvettes, making sure not to fill the cuvette more than 3/4 full with any solution.
It is also important to zero the spectrophotometer to zero out any light absorbed by anything in the solution other than the compound of interest.
Before putting the cuvette in the spectrophotometer, we cleaned 2 sides with a chem wipe. The clean sides were then placed where the light could pass through them and the lid was closed. In order to get the absorbance curve, we then pressed the read button and observed the results. Once we had determined the best wavelength to observe the data, we ran the remaining 3 dilutions through the spectrophotometer. After scanning absorbance, the cuvette was removed from the spectrophotometer and the lid was closed.
The linear relationship between concentration and absorbance of a solution. We express this relationship through the Beer-Lambert law. The Beer-Lambert law is the linear relationship between absorbance and concentration of an absorbing species. The general Beer-Lambert law is usually written as capital A equals lambda times B times C, where A is the measured absorbance, lambda is a wavelength-dependent absorptivity coefficient, B is the path length, and C is the analyte concentration. These values are determined by the reading of the spectrophotometer, and the analyte concentration is known beforehand.
We scan across all wavelengths as there are going to be different peaks. When we did our scan on the spectrophotometer, we saw many peaks, with the highest absorbance being off the screen. We chose both 560 nanometers, as that is what our TA told us, as well as 615, as that is what we measured from the spectrophotometer. These values were used as our lambda max, as it fit our data the best. Lambda max refers to the wavelength in the absorption spectrum where the absorbance is maximum. It acts as a single quantitative parameter to compare the absorption range of different molecules. Another reason we are scanning across all wavelengths is because we are using different concentrations of dilutions and unsure of what wavelength is the most accurate.